the next couple examples, I'm going to be looking for the number of moles in each compound. The first one being 150 grams of Fe2O3. And just as a bit of review, what is the name of this compound? Oxygen has a charge of -2. -2 times 3 is -6. There are 2 irons. So in order for this to be neutral charge, iron would have to be a +3. So this is iron 3 oxide. That is the name of this compound. But anyways, that's not important to what we're going to be discussing. I'm going to be looking for the number of moles in 150 grams of iron 3 oxide. Now I go about finding that by finding the molar mass of iron 3 oxide, and I do that by thinking of this as not one molecule, but breaking this down in my mind. 1 mole of iron 3 oxide is made up of 2 moles of iron and 3 moles of oxygen. So what I'm going to be doing is just breaking it down into its constituent elements, looking up their molar masses, adding all of those up together, and that will give me the molar mass of iron 3 oxide. And then from that I can figure out how many moles is 150 grams. So let me break this down into its constituent elements. I have iron. I go to the periodic table. Its molar mass is 55.85 grams per mole. And there are 2 of them, so rather than just adding another iron, I'm just going to multiply this by 2. Makes more sense. And I've already calculated all this stuff out ahead of time, so I didn't really feel like wasting a bunch of my own time. 11.7 grams a mole. Oxygen. Times 3, so there are 3 of them. And this is equal to 47.97. Tally these up. 159.7 grams per mole. And now I can find out what the molar mass is. I have 150 grams iron 3 oxide. It takes 159.7 grams to be equal to 1 mole. Now it's just a division problem, and this is equal to 0.939 moles iron 3 oxide. Have another example. This time it's nitrogen dioxide. And I'm looking for the number of moles. Now, this problem has a very stupid but quite nasty trick, and that is that it is in milligrams. And while most people probably see that right now, I know normally I see it, it's something that's very easy to overlook, especially in sciences. The more and more one studies science, grams is the standard unit for everything. And it's only in specific fields that it would make more sense for them to measure it in milligrams. And it's a very, very easy mistake to make. And it's one that I've actually had to face in my work before. I did an internship at a compounding pharmacy, and every day, day in and day out, 10 hours a day, I was making medications. And all of those formulas that I was given to make different creams, suspensions, capsules, anything, everything was given in grams. However, one day I was given milligrams, and fortunately I spotted it. But however, it could have been very easy for me to overlook milligrams. Because especially if you're working in and day out, grams, 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 all of a sudden milligrams, it's very easy just to make that mistake. However, fortunately I spotted it, but had I even missed it, pharmacies have all kinds of systems to guard against human error, because obviously people make mistakes. I check it again myself, the computer checks it, the pharmacist checks it. There are many, many checks before it exits. But every once in a while it does happen. I remember in my high school law studies class, someone presented a case. We each had to present a case. Someone else presented a case on a pharmacy or a hospital, one or the other, who accidentally gave a patient over 1,000 times what they were supposed to get. And I remember we all had a really funny laugh. It's like, I can't remember what they were saying. It was like, how are you supposed to accidentally give someone 1,000 times what they were supposed to get? It's like if I went to the grocery store and I accidentally bought 1,000 times more apples than I was going to, or I paid someone 1,000 times more. It seems ridiculous, I guess, in newspaper print, but this is the exact mistake. I'm sure it was probably this exact case. I personally had to have 10 milligrams, I think it was ethylene estradiol also, which is a hormone, and it's a very, very small amount. So I would not be surprised if it was just this exact thing, 10 milligrams. It was. I'd be willing to bet anything. It was milligrams to grams. Someone made a mistake, and that is 1,000-fold error. If I had given 10 grams instead of 10 milligrams, that is a difference of 1,000. Not a difference, but a magnitude of 1,000 difference. 1,000 times more than they were supposed to get. And in many cases, that is going to be a fatal error. So it's very important to immediately, when one is presented with a unit that is a little bit out of the ordinary, and milligrams is not necessarily out of the ordinary, it's just that grams is usually the standard unit. And I myself have definitely just ignored it and went ahead and calculated the molar mass, and then later on forgot to convert it back. So in order to preclude the possibility of myself making a gross error, I immediately convert 10 milligrams to grams. Thousand milligrams for 1 gram. This is going to be equal to 0.01 grams of NO2. So now that I've given that long explanation of why it's important to check units and convert immediately, because you might accidentally kill someone one day and get sued for a bunch of money and then be completely bankrupt so just don't do it. Now let me continue on and find the molar mass of this so I can find the moles. Nitrogen is equal to 14.01 grams a mole. Oxygen is equal to 15.99 grams a mole. And there are 2. And this is equal to 31.98 grams a mole. I'll tally these up even though that one's all the way over there. And this is 45.99 grams a mole. Now I have the grams, not milligrams. I have grams, and I convert to moles now. And this is equal to, I already calculated it out, where is it? Okay, there we go. 2.2 times 10 to the -4th moles of NO2.